Okay, so in this section, we're going to take a look at some inverse trig functions. So by now, the previous videos have been just background info, stuff that was covered in a trig class. If you're taking a trig class with me, definitely we've covered this, and I think any trig class. So, but it's been a while. That information is there, and now we're going to do some calculus with some of our inverse trig, right? And we're going to build on this from the definition of inverses, which we started the chapter covering, right? And we're going to end here. We're trying to develop three formulas that involve not integrating the inverse trig, but the results are an inverse trig function. So first, let's start with derivatives, right? Let's say that I wanted to find the derivative of an inverse trig function. All right. Okay. So one thing to keep in mind here, right? Again, here the relationship here is that the result of the inverse is the angle, right, in radians. The inverse relationship states that, well, sine y has to be equal to x, right? So we can think of y as the angle here, right? Right, and that makes sense, right? The output here is an angle. That's what y is equal to. And we know again here, SOHCAHTOA, right? Our sine is opposite over hypotenuse, which means here that this is going to be the square root of 1 minus x squared through our Pythagorean theorem, right? This being right triangle trigonometry. Okay, so let's keep that in mind here as we kind of progress here. And the derivative with respect to x of sine of y is equal to the derivative with respect to x of x. Right, so using our implicit differentiation, we get a cosine of y times y prime, and of course just 1. So we get y prime equals to 1 over cosine y. And again, looking at our triangle that we have up here, cosine is adjacent over hypotenuse. So we get y prime equals to 1 over root 1 minus x squared over 1, or just 1 over 1 minus x squared. So the derivative, right, of y prime, and we define y to be the sine inverse function, to be equal to 1 over the square root of 1 minus x squared. Okay. Okay, so now let's take a look at one more of these trig functions. And then how about the tangent inverse? So let's say that y, so here we have, before moving on, this is our desired result here, right? So we'll just kind of have that in our notes here. And now let's say that I wanted to find the derivative of the tangent inverse. Okay, tangent inverse of x. So again, that means that this is true if and only if, right, tangent of y is equal to x. So let's do the same thing here, right? Tangent y here, right? Tangent being opposite over adjacent. So we get this, and then up here we have x squared plus 1. All right, again, that comes from the Pythagorean identity. And now let's do the same thing. Let's do our implicit differentiation to determine what y prime is. So dx of tangent y is equal to dx of x. All right, and then here we get secant squared of y times y prime is equal to 1, and we get y prime is equal to 1 over secant squared, but reciprocal properties tell me that's just cosine squared y. All right, and putting it in terms of x, we see, well, cosine squared is simply going to be adjacent over the hypotenuse. So we get d dx of my tangent inverse of x to be equal to 1 over the square root of 1 plus, right? 1 plus x squared, all of that squared, or 1 over 1 plus x squared, simplifying. Okay, so that here, this one, really the bookend here, right? In simplified form is 1 over 1 plus x squared. Now, in a similar fashion, I won't go through the derivation of each one of these, but here, the derivative of the cosine inverse of x, that will be negative 1, square root of 1 minus x squared, derivative of the secant is going to be 1 over x, square root of x squared minus 1. And derivative of cosecant inverse of x will be negative 1 over x root x squared minus 1. And then the derivative with respect to x of the cotangent is negative 1 over 1 plus x squared. Okay, and what we can see here is from these four and the previous two, there's really just three different formulas, right? The other ones are just a opposite, a negative constant that's being multiplied, but it's essentially three separate formulas. So based off these quantities, we have three integral formulas, right? So now we have to add to our integral formulas. Right, so our integration formulas, right, based off these derivatives of the inverse trig, we have our first one, so integral formulas. So we have the integral with respect to du square root of a squared minus u squared is equal to 1 over a sine inverse of u over absolute value of a plus c. Our second formula would be the integral du over a squared plus u squared to be equal to 1 over the absolute value, this will be our tangent, so 1 over a tangent inverse of u over a plus c. And then lastly, the third one, the integral of du over u square root of u squared minus a squared to be equal to 1 over the absolute value of a secant inverse absolute value of u over a plus c. All right, so these are our three integral formulas, right, that involve inverse trig, right? Again, we're not integrating inverse trig functions, but these rational functions here, right, or not necessarily rational, but these functions here result in inverse trig. So now really the idea comes down to is really just pattern matching here, right? So for example, how do we apply these formulas? Okay, so our first example here is we have dx square root of 1 minus 16x squared. Okay, now notice here that it looks a lot similar. It looks like I'm going to need some kind of sine inverse, right? But it doesn't look like that form right here. When we have u, that coefficient is 1. So I need to play around with the function itself, right? So the way I do that is I'm going to factor in the denominator. I'm going to factor a 16 so that I can make that coefficient 1. Now in doing that, I have to make sure I don't change the value of the function. So I'm going to have something like this. Okay? Notice if I distribute the 16, I get back the same original function, right? It's 1, so how do I factor out a 16? I divide by 16. That's essentially what's going on here. All right, and I'm gonna take out that root 16, right? I could split it up the product. So I get 1 over root 16, but that's just 4. And I'm gonna rewrite this here. I'm gonna rewrite it as like this, right? 1/4 squared minus x squared. To kind of emphasize the pattern that I have going on here, right? And now we could see start to emerge here this sine inverse, right? Where a is going to be 1/4. Oops. So now I just apply my formula here. Don't forget to bring along this 1/4, right? The formula being 1 over a, which is 1/4, sine inverse of x over 1/4. Right, notice here these 1/4 simplify to 1. Again, don't forget the plus c. And we get sine inverse of 4x plus c. Okay. And that is how we use those formulas here.